Every one of us is wasting energy. And by wasting, I don't mean leaving the lights turned on when you have left the room, or not putting a lid on the pot when you're cooking spaghetti. By wasting, I mean we are not using the solar energy that is delivered to our doorstep by the sun every day. Just picture it, terawatts of energy flowing down from the sun to our rooftop, and yet we deny them of any purpose. We just let them heat up our rooftop shingles, or in very hot summers, our homes and everything else. Why is this important? Let me recap the status for you. We are highly dependent on energy, and we are using tons of it. And by tons, I mean 2 oil ton equivalents per person for every person on the world annually. And coming along with those 2 tons of oil everybody uses, there are 4 tons or more than 4 tons of carbon dioxide emitted into the atmosphere. Here in Austria, we have a little different situation. We have a better energy mix, so we are not emitting as much carbon dioxide, but we are living a higher standard. So we depend more on energy, and we are using up more energy. So those numbers are even higher for us here in Austria. The influence of this energy consumption and carbon dioxide emission is crucial. I'm sure I don't have to explain to you the ongoing fight against climate change. Also, I'm certain that most of you have at least thought about trying to replace or change some of their habits in order to reduce their personal carbon dioxide footprint. But hey, I have even better news for you. Using energy itself is not terrible. It depends where the energy comes from. For example, here in Austria, we have a good mixture of hydropower, and the carbon dioxide output of using this hydropower is not that terrible. Using energy again is very important for our economy. Energy drives our economy, and it keeps our standards of life very high. Globally seen again, 81% of the energy comes from fossil fuels. And that may sound terrible, but actually if you think of it, it's a big opportunity for us. Because if we go along and instead of burning fossil fuels, we swap to renewable sources, we can make a huge difference in the carbon dioxide output. Also, it is clear that at some point the fossil fuels will just vanish. We will run out of oil, coal, and gas because they've been produced over millions of years, and now we are using them up within a century, or 2-3 centuries maybe. So there's, of course, a need that at some point our society will need to change to a different energy source. And that in mind, and the climate change in mind, we just have to think about it, and maybe we will change our energy sources better earlier than later. Okay, so that sounds reasonable, but now you may ask, what can we do? What should we do in this case? This is a very good question. I can tell you a story about it, about a rethinking that has been going on among chemists and other researchers. That story may be part of the answer to the question. I myself would introduce me as catalysis chemist. Catalysis chemists are dealing with the optimization of reactions, of chemical reactions. And for a long time, catalysis chemists have been dealing mainly with oil and gas to produce plastics. So this part of chemistry has been considered for a long time as one of the dirtier sides of chemistry. And it works well, and it is needed where plastics are produced in this way, and they are being produced by taking a ton of natural gas, combine it with a catalyst, and then you get copious amounts of plastics out of it. But this rethinking that has been going on among chemists is hugely different, because a lot of those catalysis chemists that have previously been working on coal and oil and plastics have switched to a new technology that's called artificial photosynthesis. artificial photosynthesis, artificial photosynthesis may sound complicated. Actually, it is also quite complicated to perform also in the laboratory, not just here on stage. But I'll try my best to explain it to you. Basically, artificial photosynthesis is copying natural photosynthesis. Natural photosynthesis is what plants do. And plants are doing, what they are doing is they are absorbing light, mixing it together with carbon dioxide and water, and then they are producing higher molecules like sugar or wood. So in principle, they are taking two low energy molecules like carbon dioxide and water and taking the energy of the sun to produce high energy molecules like sugar. And the trick the plants are using there is their photosynthesis, and they're doing it with a catalyst. This catalyst is called chlorophyll. And you may know chlorophyll. It's purple, you can see it in the plants here. The green color is coming from the chlorophyll. And the plants have been doing this for a very long time, but they haven't been very efficient at it. Usually, we found out that they only take 1% of the energy of the sunlight that's coming in and transform it into chemical energy. So this is 99% of this energy is being wasted. And going from that, the difference between artificial photosynthesis and natural photosynthesis is quite easy. It's just that we are doing our stuff in the lab. And instead of sugar, we are producing hydrogen. We design such catalysts very specially to produce a lot of big amounts of hydrogen and live for a long time. And we also could manage to get higher efficiencies than the plants. We are reaching 7% of solar to chemical energy efficiency. Our system, it is really amazing. It's a powder, it's a dark powder that if you take a glass of water and you sprinkle in some flakes of this dark powder, that's the catalyst, and give it a good stir, place it in the sunlight, and then you take a step back and take a look at it, what's happening. As soon as the sunlight reaches the catalyst in the water, hydrogen bubbles start coming up. So this is amazing. Just to me at least, I'm sorry. This catalyst is taking the sunlight, the energy of the sunlight, and pushes it into the water, and then out comes hydrogen. And this hydrogen gas, this can be the energy carrier of the future. It is lightweight and safe to store. And it can be extremely useful when applied in hydrogen fuel cells. For example, in Innsbruck already, our cars driven by hydrogen are roaming around the streets. And we also have a fuel station. Many of you maybe don't know. The OMV, short for Austrian Mineral Oil Administration, has a fuel station just 2 kilometers from here. In my opinion, this is mind-boggling. A whole field, a whole field of thousands of people, of researchers, is swapping from plastics chemistry to renewable energy chemistry, artificial photosynthesis. That's amazing. And we are doing good work. We are going the right way, and we can show some results. Before you go to the next car dealer and try to buy a hydrogen car, I have to tell you, or I want to tell you, that this research is just in the research state. So it's not applicable yet in this manner. Our system works greatly with expensive and rare catalysts. So that's the typical problem chemists have. Things work great, but if you want to try and make it cheaper, then it doesn't work so easy anymore. We are using elements like osmium and ruthenium, probably. So even I haven't heard from them in a long time. So they are very, very rare. And we try to swap them out with more abundant chemicals. And we are on the best way to it. Nonetheless, I think the remaining hurdles can be overcome easily. And in the not too distant future, we can rely on hydrogen or other sources, mainly on hydrogen, as an alternative to fossil fuels. I would say that this technology can be available for us within the next 20 years, or even earlier when we put more effort in it. Imagine the impact. First of you, battling and winning the battle against climate change. And then, also very nice, very comfortable, not caring about when you're taking the car, when you want to go shopping, even if the supermarket is just 100 meters away from your place. So you can be lazy, it doesn't matter, because energy doesn't have a very negative effect as it is having now. Concludingly, I say we have to do something now. But we have a lot of choices what we can do. We have a lot of technologies, and we don't have to say, yeah, I would do something, but I have no choice, I can't do it. Yes, we have a lot of choices, a lot of viable technologies to help us there. Finally, I want to cite my Swedish professor. He had an accurate analogy and said, the Stone Age didn't end for the lack of stones. And the oil age will end long before we run out of oil. Okay. Thank you very much.